my locker is like right outside the door.
Good thing I always carry mine in my backpack. Red. Huh? Honestly, it's not even that heavy. I have my PreCalculus stats in there, and it's not even that heavy. Oh, that looks fun. Good thing we're not doing that.
You ready for tomorrow?
Oh yeah. Are you coming to my house at 7:30 then? It'll take me in. It's gonna, huh? Visa. Okay. My dad's making me park on the street or something.
It's Friday.
This ain't God. I want homework every day.
Oh, it's gonna be a challenge for you to wake up. Just walk away and wake up at 7:30, and then just get ready and be at 8.
No, I mean, it's really
I'm gonna get that like 6. Well, Harmonic's bringing everyone to the house at 7:30, and then we're picking you up in the house. John's too sick to go.
Or I can show your house when you're here.
Then we're gonna have like 20 cars on the street. We'll just. Gas is gonna be higher now since John Rock is sick. So instead of what did we calculate it to be? 4.5 something. It's gonna be 5 point something. $5 each. Because we figured it out. It's gonna be
I definitely
balance back.
that test.
For 12 gallons at 2.5 something. That was like.
I didn't even look at the body. I didn't look at a report
Or
of
it
the
was
body.
24 something divided by 7, but now we have 6. Hold up.
Nice book cover. Let's see it.
I know that I missed one for sure.
Sick.
Is it how you use it? What are the pictures? Tell me the pictures. You don't even need to study.
It's all common sense.
This
You know
book
like
cover's
the
out
three
of this
types of
world.
reactions? The three types of reactions. I put combination for exchange. I couldn't think of exchange. Yeah, I was totally doing that.
I'm pretty sure you're the one that said that.
Oh, you're not here?
I'm just happy I did that.
Wrong move, man.
Yeah, it's all good. Does the internet not work? Hey, you know what?
Hey, what's up with the chain gang today?
Bringing it back.
Bringing it back.
Marinara sauce.
John, I thought Johnny Marinara sauce was not coming out tonight.
Ever? It has
It'll
to
come
be.
out in
Marty, you guys marinara back?
Heck yeah.
Okay.
We dominated that. We won it like 15 to we won it 50 to 2.
50.
15 to 2.
Your third one only goes to 15?
Yeah. It's a quick game, 21.
Yeah.
So, you know, second match,
Ours
boys.
was only less, our game was less than an hour.
I know. That's unheard of. Usually like 1
Yeah,
match.
so 2.53.
That's like seriously
Yeah.
good.
No, we have the same problem you guys do. Second
Second
game.
game.
They're just tired. They
That's
think
why
they can
I
take a
don't
break. So yeah, we just the
I
second
like
game. It's always rough.
If it were
For the
$2,
first
it'd be
3 points of the
$6.
second game, I was like, if we lose this, like, we're cursed or something.
Yeah, it's second game. It's always second game. All right, today we are getting homework today. I know we are getting homework today, but we need to talk about a few things. Number one, we need to talk about fractions today. That was one topic we did not cover yesterday. We talked about what square roots are, what cube roots are, roots in general, how to simplify them, what we call simplest radical form. How you can break them down with the two methods. It doesn't matter what method you prefer. You like to break down with factors, or do you like to use the trees? Those charts I gave you. And then we talked at the very end of class a little shortcut that I have for you so that you can simplify when you have variables, like letters and powers on them. I want to review that today. We're going to start with that one first. That's something that I know that takes practice, takes time. So we're going to start with that first, then we're going to go into fractions, because that's the big deal. How do we simplify a fraction when you have it? What's the shortcuts and all that good stuff? Homework today, just kind of a mixed bag. It'll be due next week sometime. It won't be due Tuesday or by any means, because remember, we don't have class Monday. So, but it'll be due later in the week for you guys. Okay, makes sense? So, all right. So, again, the section we're in, this will be the last day of P.3. Because Tuesday we'll start P4. This is radicals and roots. So, what we're going to start with first, we're going to start with simplest radical form and variables. Again, that's kind of a main goal. Simplest radical form. And basic property that I showed you, that little power rule, how you can make powers fractions, and that's the same as a radical. Okay, so that's the big deal. Then what we're going to try to do is we're going to talk about rationalizing a fraction. Rationalizing a fraction or a denominator. So that's going to be the big thing. So the trick when we rationalize, when we get to this section, it's all about the denominator. That's what it's about. I mean, sometimes the book refers to it as rationalizing the denominator, but we're changing it to a nice, easier, clean fraction. Okay? We're going to introduce a new property when we do that. It goes on the same lines as when we simplified, so we got to talk about that. And then, yes, we will get homework today. That will be later next week. I have no idea what that is. Wednesday. Okay, all right. Any questions? What we're doing? Okay, let's jump right into it. Let's talk about the variables. So if we had let's go with an 18 x to the 5th, y to the 4th, z to the 7th, and we're going to take the square root of it. Okay, thank you. Alright, so if this is our problem, this is the one I want to jump right in to make sure that we know how to simplify it. The big deal was there's two methods. You can either do it by just traditional, factoring ways where you can just break things up into simple factors, and then you take the individual roots of each of them. If you're very good at that, you can do that. Or you can do the little shortcut rule. Which one did you guys want to work on first? You want to do the factoring thing, or you want to work on the simple formula thing, the fraction idea? Fraction idea. Okay, let's start with that first until we get good at it, and then we'll go back and look at how to do it just with factors by themselves. Okay, so what we're doing here is we're breaking this up into fractions. Now, how I'm doing this, the 18 has a power of 1 on it, and the index number is a 2, so the index number always goes to the bottom of your fraction when you make them fractions for powers. That's how it works. That's what square roots stand for, right? That you can make them fractions as a power, and that would be the same thing. You can do that in a calculator. This is actually the way that you cheat on a calculator to do radicals when they're like powers of 3s, powers of 4s, for the type of root. So like a cube root, 5th root, 6th root, that type of thing. You can use the fraction idea because you can put those powers in parentheses. All right, x. Now, what will be the power on the x? 5 halves, right? The power of 5 will be on the top. The index number goes on the bottom. The y, same thing. The power over the index number, and then the z, the power over the index number. And I distribute it. You can distribute that because really what you're doing here, the way that this works, is that it's all in a parenthesis with the half out front, and that's where the 18 x to the 5th, y to the 4th, z's to the 7th is. You're distributing this power through. It's the power to power rule, and that's what you're doing. That's why they all have half on them. Okay, any questions so far? Perfect. Okay, now, how we do this, for like the numbers you can do it by normal. Some people don't like seeing this because it doesn't make sense to have the fraction. So if you want to leave like the number by themselves, you just want to leave that root 18 out front, that's fine. You can break that down by normal means because the letters, the variables we're working with, those are the things that really benefit by doing the fraction rule. The numbers don't. 18. What can we break up 18 into? 9, 2. So, and we can take the square root of 9. So the square root of 9 is an actual 3, and the square root of 2 we don't know it, so we have to leave the square root. Remember, when you take the square root of like 9, it's just a normal whole number. Don't put the radical around it. Okay? When you take the square root of that number, it's plain, it's a whole number. Okay, so does everyone feel comfortable with numbers though? You'll have to do that quite a bit. I mean, that's the goal of your homework today, is to really figure out numbers. And then we have a few that will have variables on them. They're kind of scattered into all the different problems that we're assigning. Okay, the letters. This is the part where what I recommend you do is you make the powers you make them mixed numbers now. That way you know how to separate them. So 5 halves, what is that as a mixed number? 2.5, right? So that's x to the 2.5, which is really goofy to look at. What that basically means is that you have 2 whole x's and you have an x that has a half on it. That's what it means. You can separate them. Okay, that's what you're doing. Okay, does that make sense how I can split that up? That's what it means. Because the reason why I know I can split this up is when you multiply these together, you have to add the powers, so you still get 2.5. That's why I know you can do that. Okay, for the 4/2. Yeah, just wait a second. So that's good. That one's done. So we're gonna leave that one alone. 7 halves. 3.5. So that's z to the 3.5, which means that we have 3 whole z's and we have a z that has a half on it. That's what it means. 3 full z's and 1 that's half of z. And now what I can do is, now that I have all of this, you know, I have all these pieces, let me circle the ones that are important. These are the ones that are important. Those are all the main pieces broken down to their simplest forms. Now I'm going to put them back together to find my final answer. Does that make sense? Bringing it back. Anything that has a half on it, like for a power, especially for the letters, those will go back in the radical sign. Okay? The ones that are whole numbers, like the y, the x squared, the z to the 3rd, those go out front. Okay? So, can anyone right now kind of piece this back together and tell me what the final answer will be written as?
3x squared, y squared, z to the 3rd.
Okay, so stop there. Alright, does everyone see that those are the big whole numbers, the whole items, especially the variables? Okay, now what's in the radical?
Root 2
Okay, root 2,
x,
x, and
x, and then z.
z. Yeah, that's your answer. That's the final answer. You're done. Move on. Now, I even heard you even said it like, do we put the half on it? No. Because what does the half mean? What does the half mean? Yeah, it's the half means a radical. So we're just putting the radical around the x and the z. Okay, is there any questions with that process? The reason why I gave you this is it's a major property in pre-calc, don't get me wrong, but it makes variables easier. You don't have to think about them. You can simplify them really quickly. Really, the only strategy that you need to know is how to make these fractions. I mean, that's the main property, and how to make them back to mixed numbers, so that you know that you can separate them if need be. Okay. Now, did you guys want to learn how to do this by the traditional means, not with fractions? Did anyone want to see that? How to do it like by the normal factoring rule? Okay, so everyone seems comfortable with this. Strategy. Okay, so I rely on doing that. Okay, so you're gonna have a few with cube roots, some with square roots, where you do the same rule. Cube roots work the exact same way with variables. You can still set the power, but guess what the number will be on the bottom? 3. And then you do the same rule. You can set up your fractions and all that, and you can simplify fractions into mixed numbers and stuff. Okay, so just make sure of that. Now, if you ever had a problem that was like, say like this, so it was x to the 5th, and you're taking the cube root of it. And you're taking the cube root of it. So the idea is that, yeah, so you're gonna go, if I don't wanna use the radical, I go 5/3. That's what you guys are all saying. And then I can make that back to a mixed number. The mixed number here is 1 and 2/3, right? That's the mixed number. That means I have 1 full x, that'll be on the outside. And then I have an x in the back that's 2/3. Right? Now, let's talk about that. So, okay, so it's definitely an x out front, right? This is a whole number. So we know this little piece is out front, correct? So that's just an x out front. The radical in the back will be a cube root. It'll be a cube root, right? It's still the same root, so it's a cube root. But what's on the inside? X squared. That's what's back on the inside. The top power still goes on the x, and it goes back on the inside of whatever the radical is. So that's an x to the power 2 on the inside. So that works for any type of root, 4th root, 5th root, 6th root. If you have those like weird fractions that are left over, you still put them back into whatever the root is, and whatever number's left on the top, that's the power that's on that letter. Because I can't break down x squared any further. There's not 3 of them, so they have to be left in there. Okay, and that's your final answer, this part right here. This is what you're trying to get to. Okay, does that help you? I know some people like to see that, because, you know, I can practice these kind of all day, but until you see one where you have to do it where there's something left on the top, it kind of gets people to understand that, and understand the 2 that's left over. Okay, we good? Alright, now, I think that should get us all the way through, you know, simplifying and doing variables. That's kind of all the main stuff. You'll have a couple of square roots, a couple of cube roots. I really separate them. Then you'll have ones with variables and cube roots with variables, kind of like what I did there. You have a couple where you're going to have to add radicals together. I think we talked about that the other day, maybe. If I had to add these together, let's say 4 like this, can I add those together? No, why not? I just use some head shaking. Okay, radicals aren't the same, right? That one has radical 2, this one has radical 8. Okay, you can't add them right now. I think of radicals, they're like a variable to me. Like if they don't have the same variable, you can't add them. The thing is, on this problem, you can simplify it though. Because the radical 8 can actually break down, correct? Yeah, it's 4 and 2, right? So I can break this down to be 4 times 2. And what's the square root of 4? Yeah, so I can actually take the square root of that number and it goes to the outside. Right? And so now this turned out to be 8 root 2. Because when they go to the outside, they get multiplied. So, and now, if I just bring this down, I just go straight down. Now they have the same radical. So now I can add them together. Because now they both just have radical 2's on them. So when you add these, you just add the leading coefficients. So you're going to have 11 root 2's. That's the idea, right? You're just adding the leading number out front. It's like a variable. We have radicals on them. Okay, you can do that with cube roots, same way, you just break them down, see if they match. If they don't match, maybe it's weird and it didn't work out, then you can't add them, you're just done, move on. Sometimes they do, sometimes they don't. It works for letters too. I mean, as long as they have the same letter in there, maybe they have X's in there, you can add those, this is your answer. Even if there's letters on the outside, okay? If this is the case, where maybe you have a Y out front, okay? So I have like to this. Can I add these 2 things together? Now, that one has a Y on it. That one doesn't. The only way I can add these is if this one also had a Y out front. And now I can add them. Because now the variables are all the same. The back. Okay. So now it's 11Y square root of 2x. Alright, let's go to the fraction idea. Because this is where I want to spend like pretty much most of the time. I want to go at least the next 15 minutes talking about how do we simplify fractions. That's something that, you know, this stuff is easy. Most people understand it, or they can at least get to the point where they're comfortable at least with it. But fractions always cause a problem because it's not something that you see every day, especially when you have radicals. But I want to make sure that we know how to do it correctly because at some point in this class, at some point in pre-calc, you'll have a lot of fractions for answers. You just will. You just got to get used to it. And a lot of them will have square roots sometimes because we deal with a lot of triangles theory. I mean, that's most of pre-calc is just trigonometry, solving right triangles. I mean, that's kind of the big idea. So at some point you will have fractions with radicals on them. So we gotta be able to simplify them at least so they're back to a more manageable answer. Okay, so we'll start with an easy one. We'll start with just something very, very basic, like 2 over 7 with a radical around it. We'll start there, and then we'll try some different ones. Okay? Now, can we simplify the 2 over 7 before we start? No, they have no common factors. So what you're allowed to do is you're allowed to separate them now. So what I would do is I would make this a radical 2 over radical 7. That rule is called the quotient rule. But you're allowed to separate top and bottom. Kind of like the multiplication rule. I can separate when I'm doing a product. I can still do the product rule. Now, at this point, the rest of the problem is very simple. The whole goal now, since I couldn't do anything earlier, is just to get rid of the radical off the bottom. that's the whole point. If there's any perfect squares in any of these numbers, I'll worry about that later. But for right now, I just need to get rid of that squared off the bottom first. So the way that I believe Algebra 2 teaches, and the way that I usually do it, is whatever's on the bottom, that's what you want to multiply by. Yeah. So you want to multiply by. In fact, what I'm doing is I'm actually multiplying by the number 1. If I multiply this fraction by the number 1, does it change the answer? No. So it's still the same number, right? When you multiply by 1. But instead of just doing a 1, I'm going to choose to be like 1 over 1, which is still the same number, right? Still 1 over 1 is the number 1, and when I multiply by it, doesn't change the 2 over root 7. But instead of a 1 over 1, because that's multiplicative identity, I'm going to multiply by this. Root 7 over root 7. Because that's still the number 1 when I divide them. And now the reason why I'm doing that is because it'll get rid of the radical off the bottom. That's the whole point of rationalizing. You cannot have a radical on the bottom because that's not a rational number. You have to have a rational number on that fraction on the bottom of it. So we can figure out what the category is. So now that we do this, when you multiply fractions, you just go straight across. So I can multiply the top, which is what? 14. I'm going to multiply those two together, 2 times 7. Because they're both in radicals, that's why I can multiply. On the bottom, I get a radical 49. Now, what's the square root of 49? Yeah. Well, what should happen here is the shortcut is whatever you multiply by, it just gets rid of the radical sign in the very end. That's what you're doing. So if you know you're multiplying by 7, it'll be a 7 on the bottom later. That's the idea. Okay. And at this point, this answer is done. That's all you can do. The 14 on the top can't break down any further. Don't try to take the 14 divided by 7, because you can't divide those. One's in a radical, one's not. So you're not allowed to do anything with those. Remember, you can only do operations if they both have radicals. That problem simplified. That's your goal. There's a rational number on the bottom. Rational means it's a decimal, fraction, and or a whole number type of thing. Negatives, it doesn't matter. Cannot have an irrational number on the bottom. Okay, so let's try another one. Let's try a goofy one. Let's try one that doesn't look right. Somebody give me just a random number, please. 12, 7. All right, so 7 over radical 12. This will be our problem. So, do we have a problem?
Yes, we do.
Yeah, because the 12 is sitting there on the bottom. It has a radical sign. That's not a rational number, so we have to get rid of it. So what do you recommend that we multiply by? Radical 12. Yeah. So, yeah, you're going to multiply by whatever's on the bottom. Radical 12 or radical 12. Now again, this rule works for when you're doing square roots. Square roots, these. If it's a cube root, that's a different story. You have to choose a different number. So you have to, we'll talk about that in a minute. We'll try another one of those. This can work for variables as well. If there's a variable on the bottom, they do the same thing. Multiply by whatever's down there. Okay, so when I do this, what does the top turn into? 7 root 12. Over 12. That's how it works, because the bottom will turn out to be a square root of 144, which is 12. Now, am I done? No. Why? Exactly. The square root of 12 on the top can still be simplified. It's still manageable. So to do that, I'm going to break that up to be 4 times 3. And I have to take the square root of 4 out, which is a 2, right, when I take the square root of it. So yeah, the 7 will be multiplied on the 2, and the square root is left there. And now the reason why I didn't multiply right away is because if you want to make it a 14, that's fine. But the 2 and the 12 on the bottom can actually be simplified now, because the 2 is not a radical anymore, and the 12 on the bottom is not a radical. So I can actually simplify those. Those are common factors. So I can actually take out a 2, top and bottom, and this is your final answer. Now, if you want to make it 14 root 3 over 12, that's fine, but then you got to simplify it later. Okay, any questions with that? Now, I know some people look at that and go, well, couldn't you simplify the 12 earlier? Yeah, you could have. It would actually been a lot quicker if you did, but you still have to wait. You still have to wait the earlier. So, because it just takes more work. If you want to simplify this first, yeah, you're still going to have square roots down there. So just wait till the end. It makes it a lot easier to watch with. Okay, any questions with that? Again, use variables, doesn't matter. Now, what if I went back to the original problem, very, very original, and I did this? I just modified it a little bit. What's the problem? I got a 5 in front of the root 12. What do you think I'm going to multiply by to get rid of the weird irrational number on the bottom? I only multiply by a square root of 12. Now that's weird. You're like, well, Mr. Ward, you just told me you have to multiply by whatever's in the bottom. You only have to multiply by whatever's on the bottom if it's a square root. So you're really multiplying by whatever's in the radical sign. So that's why when I do this problem, I'm going to multiply by radical 12. Radical 12. So this will turn out to be 7 root 12, and I'll simplify that here in a minute. And on the bottom, it'll be 5 times the square root of 144, because these multiply together. And that's 5 times 12 on the bottom. Because the square root of 144 is 12. And then I can simplify from there. Does that make sense now? Like how I do that? Now again, if you do this for cube roots,